So I'm Vineet Nijhawan. I teach technology commercialization and entrepreneurship at Boston University in the business school for graduate students. I've also been an entrepreneur for 25 years and a venture capitalist. I'm pleased to be speaking to you today about technology commercialization from university research. As you know, universities in the U.S. receive close to $55 billion in research funding. Some of this research could be relevant for the market, and there's really two ways one brings new technologies to market. Either you find a need in the marketplace and then adapt technology to it, or in the case of a lot of university research where you're working on on research that's sort of interest to the faculty member and graduate students and postdocs. There's a need to sort of do that sort of technology market fit, and how one does that is really crucial to the potential success of this technology to market. So, for example, most of university research technologies are what we call platform technologies. They could be applied to many different problems. And so how you decide which problem to address first, I think, is really crucial to its success. In fact, I teach a class on that, on how to find out which first go-to-market strategy you want to employ. And it's actually not that difficult. I mean, ultimately, it's a question of iterating between all the possible applications for the technology with some criteria that you can apply, that would help you narrow down the choice of go-to-market strategy. So, in a nutshell, that's how I would approach it. So, as I mentioned, many of these university technologies are platform technologies, but they're also very early. So let's use an example. Let's say you have a 3D organ printing technology, and there are several of them being developed in universities all over the U.S. So you have this technology. So the first question is, which organ, right? And so how do you determine, should you be talking about a kidney, a liver, or some other? So you would apply some criteria such as complexity, such as patient need, such as the state of your technology, and the potential for a certain type of organ. So this stuff is way before you start talking about business models and minimal value, MVPs, which is, where sort of most of the methodologies are. So the steps that are needed to take this platform technology come down to something specific. And, for example, there's this technology out of Harvard. It's a 3D organ printing technology. We went through that process, and we went all the way from figuring out not just which organ, but down to one specific disease problem in one organ. In this case, it was kidneys, and down to one specific kind of disease within the kidney. This is what one has to do at the beginning. You really have to sort of figure out that niche that is the closest to where your technology is, because most of these technologies are very early. And you first have to go and prove that you can actually solve that one little niche problem. So you want to get to the one that's the easiest but has large enough market opportunity where you can go and sort of vet out that your technology works, and so you can also start thinking about regulatory approvals, because all of this has to go through the FDA and things like that. So, as I said, most of these university technologies are fairly early, and in order to attract, say, venture capital to to bring these things out into the market, venture capitalists, first and foremost, are going to look at the technology risk. Right? There's a market risk and there's the people risk. They're going to look at the people, of course, but if you're a postdoc or a graduate student at a good school, you're going to pass that muster, assuming that you partner with a good business person. The real thing they're going to look at is technology risk. So what you have to do is keep this technology in the university as long as you possibly can. Get it funded through NSF, NIH, SBI, however you get it funded, to basically reduce the technology risk. So you want to be able to do the proof of concept, or what I call the killer experiment, to prove that the technology actually works. If you can do that, you have a much better chance of getting it funded and out into the market. So, I've been asked the question, there are so many postdocs and graduate students in the STEM, particularly in the STEM disciplines in our schools. Many of them are not going to get academic positions. Some of them will get research positions at companies. What about the others who can't? Is going into a new venture based on your research a good way to have these people employed? Yeah, I think it could be. I mean, to give you an example, I came in to run the Office of Technology Development at Boston University in 2010, and in 5 years we launched 8 venture-backed companies that have raised over $150 million, and many of them were launched with the graduate student that was working on the technology. Prior to my being there, in 34 years, we'd launched only a couple of companies. So, yeah, I mean, I think it's very possible. But you need to organize the resources the right way. You need to bring the right kind of business skills in addition to the technical skills. And yes, it's possible. So, most universities have all kinds of resources available to graduate students to help them organize, to launch companies. And, for one, most of these universities have a mentoring program of some kind, so you should take advantage of that. 2, many of them have entrepreneurship institutes where you can meet students from business backgrounds that would form good parts of a team. 3, depending on which city that you live in, but in cities such as Boston, New York, San Francisco, there are many resources that are available outside that can help you with mentors, teaming you up with potential CEOs who can get interested in your program. In Boston we have we've talked about Venture Cafe, there's TIE, there's Mass Bio, there's the MIT Venture Mentoring Service, there's the BU Kindle Mentoring Service. I mean, there's so many of these support services. And not to mention there's lots of accelerators too, so you can take your idea and apply it to an accelerator. If you're doing something in the health science, in health tech, you would apply to Pulse. If you're doing something broader, you go to Mass Challenge. If you want to do something education technology, you go to Learn Launch. So there's all these accelerators as well that one can apply to. So you have to get out there and seek these resources that are around and get help. So, if you were to follow an academic path, in some ways it's more of a sandbox where, you get to sort of work on the things that interest you, and, you can take things to a dead end, move on to something else. As an entrepreneur, you have no choice but to be focused only on that one thing that you're trying to launch. You don't have the luxury of being in a sandbox. You have to be 100% focused only on this technology. And you have to have an enormous amount of dedication to it, because the path will be long and hard, and you have to really believe in it and focus on it. And so ultimately, if it's university research and you're spinning it out, it's trying to solve a hard problem. in the world. And if you truly believe your technology can solve that hard problem in the world, yes, there's going to be little course corrections as you get input from the marketplace. But fundamentally, the destination is not going to change. You're trying to solve a hard problem, you believe your technology can solve it. Like I said, there may be a few course corrections on the path to get there, but the destination is very clear to you. Now, if somewhere along the way you do a killer experiment and you actually find your technology is not going to work at solving that problem, then you got to give up. But until then, you got to focus on the destination. The big difference in the academic world and the business world is what I would call time constants. So in the business world, the product roadmaps in companies are usually, a year to 3 years maximum, right? Because they're very focused on what the customer needs are, holes in the marketplace, in 7, 8, 10 years. So people are working on things, solving big problems. That could take, even as, if it's a new drug, could be 15 years. And so how you sort of align these two time constants is the key. And that's an important component of why you do a startup, because companies, may not be ready to invest in a technology in the university, but a startup can gather the resources to, go prove out the technology, go prove out an early market, and then most likely get acquired by industry.